Hello everyone. Today is day 54 of my daily coding series. I'm going to look at another stack problem today. So let's just click on this one here. I've never looked at it. Okay, so this one is called Evaluate Reverse Polish Notation. You are given an array of strings tokens that represent a valid arithmetic expression in reverse Polish notation. Return the integer that represents the evaluation of the expression. Okay, return the integer that I already read that part. The operands may be integers or the results of other operations. These are the operators. Assume that division between integers always truncates towards 0. Okay, so this reminds me of, I actually have some experience with this, not Polish notation, but I was trying to write a compiler, like a calculator, and you have to use, I think it was either prefix or postfix notation. So I can see what I can do here. So reverse Polish notation. So I guess we'll click on the Wikipedia here. First ever Wikipedia on this series. Explanation. 3 plus 4, 5 plus 6, and x. Oh, okay. All right. So I think is it just postfix? Is that what this means? So if we have 1, 2 plus 3 times 4 minus. So these two are going to be added together. This one and multiplied by 3. So 3 will multiply this times that. And then you'll do, so subtraction looks like it does this. So this is the, what is it, the minuend? So it's x minus 4. Okay. So I remember when I was doing the calculator thing, I did have to use a stack. All right, so 1, 2 plus 3 times 4 minus. All right, and I just want to look at an edge case, or maybe not necessarily an edge case, but another test case. So what if we had, so 1, 1 plus is valid. 1, 1, 1 plus plus is valid. I'm going to draw another number. So I think is this valid? So plus adds two things together. Does it really not tell me Polish? Doesn't like give me a rundown of what it is? All right. So I don't know if this would be valid. My thinking is, so plus, well, it looks like it might actually not be valid because it seems like in the Polish notation, it's always like an operator, a number, and then some expression. But couldn't this also be, couldn't this also be like, so let's say we had 4, 3 plus. Okay, this is definitely valid. So couldn't we expand these into, let's say, I don't know, 2, 2 plus and 1, 2 plus, and then plus? So the whole string would be 2, 2 plus 1, 2 plus plus. Is that valid? Let me look at any examples. Yeah, so, okay, perfect. So here is exactly what I'm describing, except there's a times. Okay. So if we had another, so could we add another term to this? Like if we said 3, 3 plus, 2, 2 plus, 1, 2 plus. I don't know if this part's allowed. So this is saying, no, this doesn't. Okay, if we have a plus here, then it's saying add these two together. What if we add another plus there? So this plus, so we have to work from the inside out. So this gets evaluated, and I think that's sort of why like it's a stack. So this evaluates to 6. This evaluates to 4. Now this part, I don't know if this is allowed, if you can just do that. So then we have 3. So it's 6, 4, 3 plus plus. Is this a valid expression? I don't think so, because plus 4, 3, so then we have 6, 7 plus, which would give us 13. So maybe it is valid this way. All right, let's start with the basics, and we'll think about implementation. So if we have 1, 2 plus 3. All right, so in this case, so this is our output, right? So if I print, I just want to make sure. So if I print tokens of 0, the first one that I get should be 1, right? Okay, 2 in this, yeah. So it goes from left to right. So the way that we would add it, so if we just added all of these to a stack and didn't do anything to it, it would be 1, 2 plus 3 star 4 minus. Okay, so 1, 2 is fine. We're just adding numbers. When we add a plus, we should probably keep popping until we reach the end of the stack. And then what, do we put 3 in a different stack maybe? Okay, what if we have plus 2 plus 3, 4 in our stack, right? This is also possible. So this is the expression 4, 3 plus 2 plus, which is fine. So, okay, so if I think about how I would do that, so we would add 4 to our stack, and then 3, and then plus. So when we get to plus, we'll pop that from the stack, pop and keep popping until we get 7. And then we'll add 7 to the stack. And then we'll do another plus. No, we already did that plus. So now we'll do 2, and then we'll do plus. Okay, I'm getting it. And then at this point, so whenever we get an operator, we're going to continuously pop from the stack and then add the result of that into the stack. All right, let me try with the, did I just do it with the example? No, I just did a random one. All right, check. All right, not muted. All right, so 1, so all right, so we're gonna add 1 to the stack, and then we're gonna add 2, and then we're gonna add plus. So because it's a plus, we're gonna continuously pop from the stack until it's empty. And based on this operator, we will, so we'll say like, because it's this, we'll set sum equal to 0, and then while the stack is not empty, we'll add 2, right? So we pop those, and then we pop this, and that becomes 3. Now, once it's empty, what we're gonna do is add that value to the stack. Now we just have 3 in the stack. Okay, then we continue reading from our input. So next up is 3, and then we have star. So now, same thing, instead of starting with 0, we're going to start with 1, because that's the multiplicative identity, which means if you multiply anything by 1, it'll stay the same. Whereas if 0, if you add anything to 0, it will stay the same. All right, So then we're going to do the same thing. This is going to give us 9. We're going to pop one by one off the stack. And then we're going to have 9. And then we get 4 minus. So once we get minus, what happens? So we have to subtract this number by this number. So can we assume that there will always be 2 numbers? Because if there is, it becomes trivial. But what if is it ever possible that we could have 3 numbers in our stack? I don't know. I'm going to try that other complicated example. So if I have 1, 2 plus 3, 4 plus 5, 6 plus plus plus. And I think this is valid, a valid expression, because this evaluates, this evaluates, this evaluates. This will add those 2, and then this will add this plus this. So I think it looks good. Okay, so let's do the stack algorithm here. So we're going to add 1, we're going to add 2. Once we encounter a plus sign, we're going to replace it with the sum. And now we have 3, 4 plus, right? Because these 3 were deleted, and then we did 3, 4 plus. So what does this plus mean? So do we just pop the 2 elements off the stack? And now do we say 7 goes here? And now we get 5, 6 plus. So then do we put 11 here? And now we get plus. So then we'll combine those into 18. And then we'll get plus. We'll combine those into 21. And I'll verify it with this formula. So n is 6. So it'll be 6 times 7 divided by 2. That's 21. Okay, so it looks good. Looks good. Looks good. So I think anytime you encounter a operator, you're just going to get the last 2 off the stack. All right, so let's try implementing this. So we're going to have 1 stack only. And then we're going to say for token in tokens. All right, so, and we also want operators. And that will be plus, minus, star, and slash, like this. Stack operators. All right, so we're going to check, is our token an operator? So if token in operators, then, and then is there, should I do something if it's invalid? Like what if we get a string that's just plus, right? That's an invalid. Also division. All right, so for now, I'm going to assume, okay, valid arithmetic expression. I will assume then that all our tokens, all our input will be valid. All right, so if it's a token, we'll do stuff. But for now, let's say it's not a token, so it's a number. Then we want to say stack.append the integer version of the token. If it's a number, we always just add it to the stack. All right, so otherwise, if it is a token, we need to know what type of token it is. So let's just say for now, if token is plus, then we'll have total is 0. And then we will pop 2 things off the stack. So, well, first of all, well, yeah, I guess we never have to add it to the stack. The operator, I mean, like we never really have to add the plus. Right? Because we can never, yeah, I don't think we need it. Okay, so what I'm going to do is sum, so total plus equals the sum of, no, I'm not going to do that. Total plus equals stack dot pop. Total plus equals stack dot pop. So I'll pop from the stack twice, and that should give me two numbers. And then what I'm going to say is stack dot append total. Okay, so do I have to do an else statement for every? I'm going to do it this way for now before I over optimize. So total, so I'll just say x and y. So x, so in this case, right, it's if you have, so if you have the expression, so I'm just walking through my thought process with the minus symbol here. So if we have the expression 3, 4 minus, this means we want to do 3 minus 4 in the, if we were to arrange it in infix operation, infix notation. Okay, so when we pop, so the first one we're going to pop is here. So we'll say x equals stack.pop, y equals stack.pop. So we're going to stack.append the second one we popped minus the first one. Okay. If the token equals a multiplication, we'll say total equals 1. Still not check. All right, total equals 1. Total times equals stack.pop. Total times equals stack.pop. And then stack.append total. Okay, if the token equals division, then, so how does division, it doesn't really tell me. I'm assuming it's going to work the same way as the minus. So if I have divide, so if I have this expression, 3, 4 divide, I'm going to assume that it's 3 divided by 4 the same way that the subtraction worked. And then it truncates towards 0, so we could just take the floor of it. I think we need math for that. The math library. From math. Does that work? I'll try it. So I'm going to do the same thing here. So we're going to append x and y, and then we're going to say floor of x and y. Actually, we don't have to do that. We can do floor division. That's a built-in operator. So we can say stack.append y integer division or floor division x. And then we want to return when we're done, just like the last element of the stack. All right, let's see if this gives us errors. Okay, it worked for that. All right. I'm going to print the stack at every case and see first if there's any behavior that I didn't expect. All right, so we have 10, 6, 9, 3. That looks good. When we do plus, we're going to add 9 plus 3 and add it to the stack. All right, negative 11 gets added to the stack. Multiplication gets added to the stack. So now it's going to be 11 times 12. That is what that equals. Division gets added to the stack. So we're going to do 6 divided by 132. So shouldn't that be 0? Oh, 6 divided by negative truncates towards 0. I think the division is what's messing it up. So let me print x and y, and then let me print y. So let me print what the normal division is and then what the integer division is. So I'm going to try that again. I think everything was good up until that point though. Okay, so we have check. Oh, sorry, I had to sneeze. All right, so we have a x and y. So all right, so this is not. So we could add an if statement. Okay, so this should be 0, but it's 1. So I'm thinking, so we should just add, so if it's negative, so we could say quotient equals y like that, and then if quotient is less than 0, quotient plus equals 1, then we'll append quotient. I'm thinking that will work. So it looks like it always rounds down, but we want it to round towards 0. So in that case, we actually want it to round up if it's negative. Okay, we passed the case. Wrong answer. All right, so let's look at this one. So it adds 4, adds -2. Then it divides, so 4 divided by -2 is -2. Are we not adding it to the stack? We are. So why don't I see it? Why don't I see stack here? So my thinking is this -2 doesn't look like it's getting added back in the stack, which it should be doing. Oh, I didn't save the test case. That's brutal. That is brutal. All right. Let's run it back. I see. So because it's exactly even, it's adding -1 instead of -2. So maybe instead of +1, we could say and y mod x does not equal 0. So if it's exactly even, then we actually don't want to add to that. Yeah, perfect. So it was adding to -1. All right, so there's some tricks there with the division. Right. Is there a different way that I could do this besides doing an if statement for every operator? I mean, this... Whoops. I mean, I could make a function because this is equal to total plus. So we could have some function that takes in an operator and what? Takes in an operator and what? I mean, I could shorten it so that these two, I mean, I could make these two work in one function. These two, they're really different because of all this stuff. I think I'm just gonna leave it at that for now. Yeah, I'm gonna leave it at that for now. I think it's fine. It's just a lot of code because each one is different. Well, I'm noticing actually, so each one requires 2 pops of the stack. So maybe I could say x equals stack dot pop, y equals stack dot pop. So then we can get rid of these. So here we could just say, and maybe we could say like result equals x plus y. So we can have each function or each if statement be, it generates a variable called results, and then after, because I noticed each if statement pops twice and does something. So here we can like to those pops. So then here we could do y minus x. Here we can say result equals x times y. That gets rid of a lot of code. And now this part, we don't need this. We don't need this. Whoops, we don't need this. So we'll append res. So we can say results, and then just change those. All right, so that looks a lot simpler. I want that like this. All right. Maybe I could say if token not in operators. Maybe this would be better. So this is the general case. All right, yeah, I think that looks a lot better. Yeah, it should still work. Yeah, perfect. Okay, great. And yeah, all right, that's awesome. So then it depends what we like. Right now, I'm the stack after this method, after this function is empty. I could also say just peek at the stack like that, but I think it's probably better like this way. Yeah, so I'm gonna look it up now on LeetCode. So it is problem. I'll just evaluate reverse Polish notation. Evaluate reverse Polish notation. And let's see if our code works. All right, yeah, looks good. Looks like I kind of got the most common solution, which makes sense. Yeah, I'm happy about this one. These stack problems are a lot. You think, I don't know, at least for me, stack was one of the first data structures that I learned. So you would think that they would be really easy, but I'm having a good amount of challenge with these problems. So I'm enjoying the stack problems right now. It's a nice sort of break before I go back into advanced graphs and 2D dynamic programming. just kind of doing these more simple graph problems. But yeah, thank you guys for watching. That was today's episode, and I'll see you tomorrow for I think it's day 54 tomorrow. Or was that today? I don't know. I'll see you tomorrow. All right, bye.